Question 1, work out the value of root t over 20, where t is equal to this. Okay, without a calculator, guys. This is, t, which is hang on, before we do the root, guys. What is 2.42? 2.42 times 10 to the power of 3 over 20. Now this is equal to 2420 over 20. I will get rid of the zeros, and this is equal to 242 over 2, 121. Now this is the square, it's the square root of this, so I'm just going to do the square root of 121 equals 11. So that's 11. To factorize this is the difference of two squares, guys. 1 mark, it's x plus y times x minus y. Definitely we need to know that. If you multiply it out, you'll see exactly why that is the case. That's question 2. Question 3. Nth term of a sequence is this. Circle the limiting value of 3n plus 4 as n approaches infinity. Okay, the answer, guys, is 3, because it's basically the 3, the coefficient of n on the top, over the 1, the coefficient of n on the bottom. 3 over 1. When n gets large, when it gets really, really big, this 4 kind of doesn't really play a big role. So what happens is it approaches 3. The equations of two straight lines are this and this. Show that they are parallel. Okay, so first line, y minus 3x equals 4. This is y equals 3x plus 4. Therefore, m equals 3. This guy, 6y equals 18x minus 5. Y equals this divided by 6, which is 3x. This divided by 6, minus 5 over 6. Therefore, m equals 3. Now it says show they are parallel, so you have to say, guys, gradients are the same. Gradients are the same, are both 3. Therefore, parallel. That's question 4. Question 5. Y equals this, work out dy dx. Okay, first thing, guys, I'm going to write this as y equals 4 x to the power of, now I'm going to do these separately. This divided by this, 3 minus 4 is minus 1. And x to the 7 over x to the 4 is x cubed. Okay, now I'm going to differentiate this, dy dx, is multiplied by the power, minus 4x, subtract 1 from the power, minus 2, and then plus multiplied by the power 3x, subtract 1 from the power, squared. So it's just minus 4x to the minus 2 plus 3x squared. You can write it as minus 4 over x squared if you want, but it's the same thing. Question 6. Points A and B lie on a circle. AB is the diameter. Work out the equation of the circle. Okay, so if this is the diameter, the radius is half this length, and the center is the midpoint. So let's do the midpoint first. The center. The center will be x1 plus x2, x1 plus x2 over 2. That's actually going to be 0. And I see this is also going to be 0, guys. This is 1 plus minus 1 over 2, which is equal to 0, 0. So the center of this circle is 0, 0. The distance AB, the length of AB, is equal to the square root of x1 minus x2 squared, so it's minus 12 squared, plus y1 minus y2, which is 1 minus minus 1, which is 1 plus 1 squared. This is equal to, I don't have a calculator. This, guys, is going to equal to, now, sorry, that's 0, 0. I just realized, guys, it's probably easier, in fact, it's definitely easier to, it's definitely going to be easier to get the radius by getting the, let me get rid of that guy, sorry. I'm going to get the radius by getting the center, the distance between the center and one of these points. So let's try that again. Radius is going to be the square root of, so it's like minus 12 minus 0 squared is x1 minus x2 squared. So that's just going to be 12 squared plus 1 minus 0 squared, which is 1 squared. So that is actually going to be, that's 12. This is going to be 12 squared, which is 144, plus 1 is 145. So it's the square root of 145. The equation of the circle is therefore x squared plus y squared equals 145, because it equals r squared. X squared plus y squared, because the center 0 is 0, so normally it would be x minus this plus y minus this, but obviously minus 0 is just itself, so that's the answer. Okay, question 7. A point P is transformed using the transformation matrix represented by this. The image of P is this. Work out values for x and y. Okay, so we're going to do this, guys, 4 minus 2, 0, 3. This times sum xy, because we're going to transform this point using this matrix. So this matrix times this point gives us minus 8, 7. So multiplying out the matrix by this times this and this times this, row times column, 4 times x is 4x, plus 0 times y is obviously just 0. Then minus 2 times x is minus 2x, plus 3y. Okay, so this equals negative 8, 7. We can then just equate the top, sorry, it's negative 8, 7 like this. We can then just equate the top, so 4x equals negative 8, x is equal to negative 2. And the bottom one, minus 2x plus 3y equals 7. We have negative 2. Negative 2 times negative 2 is 4. So 4 plus 3y equals 7. 3y equals 7 minus 4, which is 3. Y is therefore equal to 1. Okay. Question 8. Solve by factorizing. Okay, first step, guys, we will take out the x, the common factor. There's an x in all of these. So take out the x, then I've got 2x squared minus 9x minus 5 equals 0. Then this thing, the quadratic, let's do my a times c. A times c is negative 10. Factors of negative 10 to give me negative 9 is definitely negative 10 and 1. This thing then becomes, let's just do it here, guys, 2x squared minus 10x plus 1 minus 5. This is 2x into x minus 5. Sorry, that's 1x if you like. Plus 1 into x minus 5. Factors are therefore x times 2x plus 1 and x minus 5. This equals 0. Therefore, x equals 0, 2x plus 1 equals 0, or x minus 5 equals 0. This one's just 0. This one is negative 1 over 2. And this one is just 5. Okay, 1, 2, 3 solutions. Okay. Question 9. A, B, C, D, E, F, G, H is a cuboid. Work out the length of A, G. Okay, so let's just draw, guys. This is A, G. 1 second. This is AG. Now, I think definitely, guys, we're going to go back to here. Let's make this a right angle triangle. Okay, this is right angled, guys. This is a right angle here, even though it doesn't look it. Okay, now we're trying to get this length here. We know this one is 12. This is just 12. And this one we can get, guys, because look, this is 3. So this triangle down at the bottom, this is actually a 3, 4, 5 Pythagoras' theorem triple there. So look, this is a right angle triangle. This is 3, this is 4, this is 5. Just in case you're not clear why, guys, x squared equals 3 squared plus 4 squared. X squared equals 9 plus 16 is 25. X is equal to the square root of 25, which is 5. So that's 12. That's 5. This is then actually, guys, it's another triple. This is 13. Let me just show you why that is the case. Let's call that y. Y squared is then equal to 12 squared plus 5 squared. Y squared is equal to 12 squared is 144. 5 squared is 25. Y squared is equal to 169. Square root of 169 is 13. Okay, that's it. Question 9. Question 10. A function f is given by this. A sketch of the graph is shown. So it's a straight line and a quadratic. Work out the values of a and b. Okay, first thing to note, guys, is they meet here at point P. So they must be equal at that point. So that point is 2, because it's where the line finishes here at 2 and the quadratic begins. So f of 2 here must equal to when I sub 2 in here. So I'm going to sub 2 into them both. So minus a half times 2 plus 21 must equal a times 2 squared plus b times 2. Okay, this is minus 1 plus 20 is, sorry, minus 1 plus 21 is 20. So this is 20 equals, this is 4a plus 2b. Divide everything by 2 just to make it simpler. 10 equals 2a plus b. Okay, so we have that one equation. Then I have this point that I haven't used. So I can just sub this into the quadratic. So I can say f of, let's just write it here, f of 6 equals 12. So that means when I sub in 6 in here, a times 6 squared plus b times 6, this must equal 12. 36a plus 6b equals 12. Multiply divide everything by 6. This gives me 6a plus b equals 2. Okay, now I have, everyone, 2 equations which I can solve simultaneously. Okay, I'll just do it over here, guys, so we can see everything. So this is 2a plus b equals 10. This is 6a plus b equals 2. Same sign, subtract them. 2a minus 6a is minus 4a. 10 minus 2 is 8. A is 8 divided by negative 4, which is negative 2. That makes sense that it's negative, guys, because it's a sad face, if you like. Okay, so a is negative 2, and then I can sub this into any one of the ones to get b. Let's just do it into that first one. 2 times a, so 2 times negative 2 plus b equals 10 minus 4 plus b. Minus 4 plus b equals 10, b equals 14. So a equals negative 2, b equals 14. Okay, that's question 10. Question 11. A. 3x minus 7 is a factor of this. Work out the other two linear factors, right? We have to do, guys, in this question, this long division. So we do 3x minus 7 into 3x cubed minus 4x squared minus 13x plus 14. So we do 3x into 3x cubed goes x squared. This times this is 3x cubed. This times this is minus 7x squared. Line underneath. Subtract. This minus this is 0. This minus this, well, it's this minus negative 7 gives me plus 3x squared minus 13x plus 14. 3x into 3x squared goes x times, so x squared plus x. X times 3x is 3x squared. X times minus 7x, sorry, x times minus 7 is minus 7x. Line underneath, subtract 0. This minus negative 7 is going to be minus 6x. Bring down the 14. Keep doing that. 3x into minus 6x is minus 2. Minus 2 times this is minus 6x. Minus 2 times minus 7 is plus 14. Subtract it, I get 0. Okay, now they have kindly given us loads of space as always, so I just need to factorize this quadratic. So this is x squared plus x minus 2. So just to be clear, guys, the factors are now this and this quadratic, but he wants two linear factors, so I just need to factorize this. This is equal to, it's x and x, factors of negative 2 to give me 1 is going to be plus 2 and x minus 1. So x plus 2 and x minus 1. Okay. 11b. This is a factor of this. Work out the value of a. Okay, so we don't have to do long division here, guys. We can just use the factor theorem. If x minus 2 is a factor, then f of 2, let this equal f of x. Then f of 2, guys, must equal 0. So if I sub 2 in for x here, I'm going to get 2 to the power of 4 is 16. So it's 16a. Let's do the whole thing. Oh, sorry, that's too much. So a into 2 to the power of 4 minus 3a 2 cubed plus 5 times 2 minus 22 equals 0. Right, this is 16a. This is 8 times 3 is 24, so minus 24a plus 10 minus 22 equals 0. And we just have to get a. 16 minus 24 is minus 8, so minus 8a minus 12 equals 0. Minus 8a equals 12, and a is 12 over negative 8, simplifies to negative 3 over 2. Okay, that is question 11. Question 12. In triangle ABC, cos A is this. Work out the length of BC. So cos of A is this. So we don't have the angle, but we do have the cos of the angle, which is actually even better. So this is actually easy, guys. It's cosine rule. I can just say x squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times cos of A, which is times 3 quarters. Okay, x squared is therefore equal to 144 plus 100 minus, okay, let's do this. Let's go 2 into 2 goes once, 2 into 4 goes twice, 2 into 2 goes once, 2 into 10 goes 5 times. So it's 5 times 12 is 60. 60 times 3 is 180. Okay, so x squared is 244 minus 180. This is a nice number, guys. It's one of the ways you know you're right. 244 minus 180 is 64, and then x is the square root of 64, which is 8. So x equals 8. Question 13. A garden patio is made from two rectangles. All lengths are in meters. Area of the patio is less than 51 meters squared, where the range of possible values of x. Give your answer in this form. A and b are both integers. You must show you're working. Okay, let's go with, guys, you can break it up two ways. You can break it up this way or this way, which is what I'm going to do. Let's do that properly. Okay, so the area is 7x, this times this, plus this times this, 8 times x minus 3. And this has to be less than, this has to be less than 51, because this is the area. Now, I'm just thinking what the lower bound is going to be. Well, the lower bound, x has to be bigger than 3 because of this. If x is less than 3, like if x was 2, then it would be no good. So x has to be greater than 3. If it was less than 3, this would be a negative number, which makes no sense. So a is actually equal to 3 straight away. A equals 3. And then to get b, we'll just solve this. So this is 7x plus 8x minus 24 is less than 51. 15x is less than this plus this, which is 75. And divide by 15, this has to be less than 5. So the final answer is x is greater than 3 and less than 5. Question 14. Write this in this form. Okay, complete the square, guys. We are going to take out the 2. And here we have x squared minus 8x, and just leave the 7 over here at the side. Then in the square bracket, we're going to do this, complete the square trick, which is we half the 8, so it's x minus 4, square it, and then we always subtract this squared, because that's kind of what's the extra thing that appears when you multiply this out, which we don't want. So we subtract that 16, subtract this squared, and then plus 7. You then multiply out, you get 2, x minus 4 squared. 2 times minus 16 is minus 32, plus 7, and this is 2 times x minus 4 squared minus 25. Okay, that is 14a. 14b is then to solve this. It's only one mark, guys. Add the 5 over here, so it's x minus 1 squared equals positive 5. Square root both sides, x minus 1 equals square root of 5. Now it's plus or minus root 5, and therefore x is equal to add 1, 1 plus or minus square root of 5. Question 15. Matrix M represents a reflection in the line y equals minus x. Write down the matrix. Okay, I'm going to just draw this, guys, which I like to draw. This is our identity matrix. So our identity matrix is our 1 0 1 0 here, and our 0 1 here. So it's 1 0 0 1. Now if we're going to reflect it in the line y equals minus x, which will be this line here, let's say this is the line y equals minus x, this guy goes down here. So let me just change the colors actually, guys. So the red guy goes down to here. So instead of 1 0, I'm going to have 0 minus 1. So this is going to be 0 minus 1. And this orange guy will go to here. So this is minus 1 0. I'll just put it in orange, but obviously, guys, you'll keep it in the same color. Okay. N is this. Describe geometrically the single transformation represented by n squared. Okay, let's square it first. So 0, 1 minus 1, 0 times 0, 1 minus 1, 0. So as usual, guys, this times this is 0. This times this is negative 1. That's the top left. Top right, this times this is 0. This times this is 0. Bottom left, this times this is 0. This times this is 0. And bottom right, this times this is minus 1. This times this is 0. Okay, so we're left with a matrix of minus 1, 0, and 0, minus 1. Okay, now what has happened to this? Again, okay, let's just draw this again. Okay, our 1, 0 is here, and our 0, 1 is here. The 1, 0 has moved to minus 1, 0. So he has moved, this guy has moved to there. And our 0, 1, this is just, sorry guys, I should have written our identity matrix. So our 1, 0 has gone over there, and our 0, 1, this guy has gone to 0, minus 1. So he's gone all the way down, he's gone all the way over there, and he's gone all the way down there. So what's actually happened is, well, it's just a rotation, because he has rotated to there, and he has rotated to there. Now you could say, is it not a reflection because he's just gone over there? Well, it's not, because if it was a reflection, he wouldn't have gone down there. So he's reflected in the y-axis, and he's reflected in the x-axis, but you can't do that in one transformation. So it's a rotation. So it's a rotation, let's just write it here, rotation of 180 degrees. Normally I'd say clockwise or anti-clockwise, but it's actually the same thing, so it doesn't matter. Rotation of 180 degrees, and you have to say about center 0, 0, or the origin. Okay, that's 15. Question 16. A, B, C, D are points on a circle. Angle OBC to angle ODC, so is 5 to 3. Okay, so let's just call this, guys, what did he say? OBC to ODC. Let's call that 5x. And let's call this 3x. Okay, then if this is 52, this is 104. It's double. Angle at the center is double angle at the circumference. Then, if this is 52, this has to be 180 minus 52, because opposite angles in a cyclic quadrilateral add to 180. So this minus this is 128. So this is 128. And now I have a quadrilateral on its own, this little quadrilateral, and these all add to 360. So let's do this. 104 plus 128 plus 8x equals 360. This plus this, 2, this is 232. 232 plus 8x equals 360. 8x is therefore 128, I believe. 128. And x is therefore 8 into this goes 8 into 12 goes once, remainder 4. 8 into 48 goes 6, so it's 16. So x is 16, but he wants OBC, so he wants this angle here, which is 5x. So let's say OBC equals 5x. 5 times 16 is 80. So it's 80 degrees. 80 degrees. Okay. Question 17. Show that this simplifies to this, where k is an integer. Okay. Firstly, guys, I want to factorize this thing at the bottom because I need a common factor. Now, I know it's x minus 2 is one of the factors. So let's just do it the long way. So 21x over, 3x squared minus 2x minus 8. A times c, let's just do this separately, guys. A times c is 3 times minus 8 is minus 24. Factors of minus 24 to give me this are 6 and 4 minus 6 and 4. So I do 3x squared minus 6x plus 4x minus 8, 3x into x minus 2 plus 4 into x minus 2 equals 3x plus 4 times x minus 2. Okay, so this thing is therefore equal to 21x over, I'm just going to write it as factorized form here, 3x plus 4 times x minus 2. And then this guy, we're going to do a common denominator. Let me just bring it down here, guys, because I feel I don't have space. Common denominator, which is x minus 2, but I'm going to multiply by, and then this is 7. So 7 over x minus 2. I'm going to multiply the bottom by 3x plus 4, and then I'm going to multiply the top by 3x plus 4. Okay, now I can combine these. I can say this is equal to 21x minus 7 times 3 is minus 21x, and then minus 7 times 4 is minus 28, all over 3x plus 4 times x minus 2. Now he wants the quadratic expanded at the bottom, guys, so I can do that, but I know what it is expanded. It's just this, because that's how I got it. So this minus this is 0, so I'm just left with minus 28 over 3x squared minus 2x minus 8, and we're done. That is 17. Question 18. Rationalize the denominator and simplify fully. Okay, so we have to multiply above and below by the conjugate of the denominator. The conjugate is just going to be root 5 plus root 3. So it's this over root 5 plus root 3. So we're not changing the value. We are just multiplying by 1, essentially. So we do this times this, and this times this. Okay, so top, let's do the top first. This times this is going to be 15, because 3 root 5 times root 5 is 3 times 5, which is 15, because root 5 times root 5 is 5. This times this is going to be 3 root 15, because root 5 times root 3 is root 15. Then this times this is plus 1 root 15, or just root 15. And then this times this is plus 3. Root 3 times root 3 is 3. Okay, denominator, root 5 times root 5 is 5. Root 5 times root 3 is root 15. Minus root 3 times root 5 is minus root 15, and these two are going to cancel, which we knew. And then minus root 3 times root 3 is minus 3. Okay, then we're going to add the top. 15 plus 3 is 18, so it's 18 plus 3 root 15 plus root 15 is 4 root 15. And then the bottom is, these cancel. 3 minus 4, 5 minus 3 is 2. And then simplify this, we get 9 plus 2 root 15. Okay. Question 19. Equation of a curve is this. Work out the stationary points of the curve and determine their nature. Okay, stationary points, guys. I've done this before. Stationary points, dy dx equals 0. And determining their nature, d2y dx squared equals question mark. Okay, so first let's get the first derivative. Let's do it over here. Y equals x cubed minus 3x squared plus 5 dy dx equals 3x squared multiplied by the power minus 6x. Okay, and this equals 0. 3x squared minus 6x equals 0. Divide by 3. X squared minus 2x equals 0. Take out the x. X into x minus 2 equals 0. X equals 0 or x equals 2. Now, when x is 0, y equals, because remember, y equals x cubed minus 3x squared plus 5. So when x is 0, y equals 0 minus 0 plus 5, which is 5. Or here, I'm going to have 8 minus 2 squared is 4. 4 times 3 is 12. So 8 minus 12 plus 5, which equals minus 4 plus 5, which is 1. So the 2 points are 0, 5, and 2, 1. Those are the two stationary points, but we need to determine their nature. So let's get the second derivative, d2y dx squared. That is the derivative of this. So it's going to be 6x multiplied by the power, subtract 1 from the power, minus 6. Okay, then we say when x equals 0, d2y dx squared equals minus 6, which is less than 0. Therefore, if it's less than 0, this is a max. When x equals 2, this guy, d2y dx squared is equal to 6 times 2, which is 12 minus 6, which is 6, which is greater than 0, therefore a min. So that means, okay, well, we have it here. Stationary point is 0, 5, and this guy is a max. And then 2, 1, and it's a min. Question 20. Here's a graph of this. Okay, fine. What are we dealing with? By drawing a suitable straight line, work out approximate solutions to this. Okay, so let me get this down here, guys. It's y equals minus x squared plus 3x plus 6. Y equals minus x squared plus 3x plus 6. Okay, now this guy is our equation. X squared minus 7 over 2x minus 3 equals 0. Okay, first thing to do is, well, what my goal is to change this thing into this thing. I'm going to turn this into this, and I'm going to do that by solving, or by rearranging this and not breaking any rules of maths. So the first thing is, he's got a minus x squared and I've got a positive x squared, so let's make it minus. But I can't just make something minus. I have to use some rule of solving equations. In this case, I'm going to multiply across by -1. So change all the signs. That becomes minus, this becomes plus, and this becomes plus. And this is just 0, so you can change the sign of 0 if you want. But it's still 0. Okay, so now this is the same. Next thing I want to be the same is the 3x. This is 7 over 2x. This is 3x. What do? Well, I subtract, so minus x squared plus 7 over 2x. I'm going to subtract 1 over 2x, because that will give me 6 over 2x, which is 3x plus 3 equals. But if I subtract minus 1 over 2x from the left, I subtract 1 over 2x from the right. Okay, now this is minus x squared plus 3x. Nice, this is the same. But I have a plus 3 here, and I want a plus 6, so I just add another 3. So minus a half x plus 3. So the whole idea is, guys, that solving this equation here is the same as solving this equation. And to solve this equation, I can use the graph of this, which I have, and then I'll draw this line. So draw line, y equals minus half x plus 3. Let's draw that. Y equals minus half x plus 3. Okay, my preferred way to draw a line, guys, is just to get 2 points. So I'm going to get x and y like this. And then I'll go, well, when x is 0, y is 3. And then just pick another one. Ideally one that'll work out nicely. Why not go with 4? When x is 4, y is 4 over 2 is 2, so it's minus 2 plus 3, so it's 1. So it's here. And actually, guys, that I think is going to be, oh no, sorry, it's 1. 4 and 1, which is like there. Okay, so 0, 3 is here, and that's 0, 3, and this is 4, 1. So I just have to draw a line straight through these two here like so, and let's just draw it back like this. Okay, that kind of makes sense, guys, because is my gradient minus a half? Well, it is, because this is 2, and this is 1, 2, 3, 4. 2 over 4 is a half, and it's going negative. So that's the correct line. Then what I essentially want to find is where these two meet here. So there, that's going to be like minus 0.7 maybe, minus 0.7. And this one's going to be, well, this one's almost bang on 4.2. Sorry, that should be straight down. So these are going up in 0.2. So look, that's negative 0.2, 4, 6, 7. So this is negative 0.7, and this is just 4.24685. So that's 4.2. So negative 0.7 and 4.2. So x equals negative 0.7, comma 4.2. Okay, 21. Work out the possible values of x. Okay, guys, I've seen these type of questions before. Let's put everything into base 2. So this is already in base 2, so it's 2 to the power of this to the power of this. A power to a power, guys, is we multiply out the powers. So it becomes 2 to the power of x plus 3 times 4x plus 1. And this equals 2 cubed to the power of x minus 1. Okay, this is then equal to, let's multiply this out, guys. This is, oh no, let's not yet. It's x plus 3 times 4x plus 1 equals 2 to the power of 3x minus 3. Okay, now when the base is the same, you can just equate the powers. So x plus 3 times 4x plus 1 equals 3x minus 3. Now, guys, you could have, of course, multiplied these out a long time ago. You could have done it in step 1, but whatever. This times this is 4x squared plus x plus 12x plus 3 equals 3x minus 3. Okay, so this is then 4x squared. Let's do it here. 4x squared. X plus 12x, 13x minus 3x is going to be 10x. And then 3 plus 3 is plus 6 equals 0. Divide everything by 2. 2x squared plus 5x plus 3 equals 0. And then we will factorize this. Let me do it over here. A times C equals 6. Factors of 6 are 3 and 2, which add to give me this 5. So I have 2x squared plus 3x plus 2x plus 3 equals 0. Take out an x, 2x plus 3, plus take out a 1. This is no common factors. 2x plus 3 equals 0. And then 2x plus 3 times x plus 1 equals 0. Final answer, x is then going to be negative 1 or 3 over 2. So x equals negative 1 or negative 3 over 2. Or negative 3 over 2. That's just because this would equal 0. 2x equals negative 3. X is negative 3 over 2. And this one's obviously negative 1. Okay. Question 22. Second last question, I believe. Simplify f of x and hence solve f of x equals this between 90 and 180. Okay. Okay, let's have a think. We can, my first thought, guys, is to factorize the top. I'll take out the sine x. So I have sine x, then I have 3 cos x plus sine x. And then at the bottom, I'll take out a 4 cos x. So 4 cos x. And I have 3 cos x plus sine x. Now that's super nice because this whole thing here is going to cancel with this here. Okay, so this is then equal to sine x over cos x, sine x over 4 cos x, which is actually a quarter. Sine over cos is tan, so it's a quarter tan x, or tan x over 4, same thing. Okay, then a quarter tan x equals this. We're going to solve this. Root 3 over 4. Multiply across by 4, get these 4's disappear. Tan x equals negative root 3. Okay, now I need to solve this within here. I'm going to get the acute angle. Inverse tan of root 3. That's one of those ones that you have to know, guys. Root 3, it is 60 degrees. This is 60 degrees. And then I'm going to go to my cast diagram here. C-A-S-T. My acute angle, it has to be negative, so it has to be in S or C quadrant, but he's already told us it's in this quadrant, it's here. So I then just go, right, 60 degrees from 180, so it's 180 minus 60, so this is 60 here. So what's the green angle? Well, the green angle is 120. So therefore, x equals 120 degrees. Okay, that's 22. Last question, guys. Question 23. The nth term of a quadratic sequence is this, where a and c are integers. The first 4 terms are these. work out the value of x and y. Okay, so let me have a think. So we actually have lots of unknowns. So what I'm actually going to do is I'm going to say, right, when n is, let's use these two first. We'll use this one and this one. So this is n is 1, 2, 3, 4. This is like n, and this is like u of n, if you like. Okay, so when n is 1, u of n is 2. So that means a times 1 squared minus 5 times 1 equals 2. Okay, sorry, there's a c there, which I forgot. Plus c equals 2. That means a minus 5 plus c equals 2, which means a plus c equals 7, if I add this to this side. Okay, a plus c equals 7. Then I'm going to use the 16 one. I'm going to say a times 3 squared minus 5 times 3. So when n is 3 plus c, I get 16. Similar situation. This is 9a minus 15 plus c equals 16. 9a plus c equals 31. Okay, I have simultaneous equations. Let's solve these. 9a plus c equals 31. A plus c equals 7. Subtract. 9a minus a is 8a. These disappear. 31 minus 7 is 24. Therefore, a is equal to 3. Okay, if a equals 3, just from this one here, 3 plus 4 equals 7, so c is equal to 4. Okay, let me highlight this. A equals 3, c equals 4. Okay, so now I have the nth term without a and c. I can say the nth term is 3n squared minus 5n plus 4. Okay, so now I just have to find x is when n is 2 and y is when n is 4. So let's just write here when n equals 2, the nth term is 3 times 2 squared minus 5 times 2 plus 4, which equals 12 minus 10 is 2. 2 plus 4 is 6. And then when n equals 4, 3 times 4 squared minus 5 times 4 plus 4 equals 16 times 3 is 48. 48 minus 20 is 28. 28 plus 4 is 32. So x is 6 and y is 32. X equals 6, y equals 32. Okay, that's it, guys. That is the end of the paper. Hopefully paper 2 will be done shortly.